welcome back. As some of the commenters under my last video pointed out, I made a major mistake when I glued in and aligned the stop pins on my Dbit grinder for the 90-degree swivel motion. The problem is that the 90-degree relationship that I formed is only given at a certain radius. If you change the position of the eccentric stop pin by adjusting it, the swivel motion is not 90 degrees anymore. So I have to remove those pins and glue them in new. They are Loctited in, Loctite 648, which is a high strength retaining compound. And the easiest way to get them out is Oxy-fuel. You just heat them until all the Loctite has burned off, and then you can freely move the part. Loctite can basically not be released with solvents. You can, if you look in the technical data sheet for Loctites, most of them resist, for example, acetone, basically almost forever. So that's the reason why I'm using the Oxy-fuel torch here, giving it good heating and then moving the pins with the screwdriver. And yeah, I'm fully aware that I'm burning off the paint on the other side and also the Bondo. You can see the broken free pin. And I can take them with a plier and pull them out completely. The Loctite has burned off completely. There is nothing of the Loctite left. As you can see, my Oxy-fuel setup is not what it used to be. I used to have a small 2-liter bottle in here, but those bottles are getting harder and harder to get either refilled or exchanged against a full one. And they are super expensive to get refilled. It costs the same to refill the small one than it is to exchange the 10-liter bottle here against the full one. I think the 10 liter is even a little bit cheaper to get refilled. But as you can see, I don't have a rig to put the propane and the oxygen together on a cart or something like that. That's a project for the future, to build a small, low-profile cart to have the 10-liter bottle and the 5-kilogram propane bottle instead of the small one-time used propane bottle that I used to use down here. So that's something for the future. But being the good role model I am, I ratchet strapped the oxygen bottle against something solid so it doesn't tip over when in use. Another exciting episode of Glue That Pin In. This time, hopefully, the right orientation. So what I did previously was I had a Dbit in here, which is split to half its diameter. And that made, in this alignment, the center line of the stop pin perpendicular or in line or goes through the center line of rotation. If I do that with both of the pins, like I'm simulating here, so now they are both of the surfaces are running through the center line of rotation here. So I have my drafting square here, and when I carefully align it with one of them, you notice that the other pin is not, that this is not 90 degrees between those two pins. That's a problem. The point that is on center line of this banana-shaped slot here, between those 2 points, that's 90 degrees in relation to the center line. But it's not if we use the eccentricity of the stop pin in the other part. Then the angle does change. I will show that later. I have a printout that shows that a little bit better. So what I came up with instead is I have the stop pin has a 5mm end. It rests against these faces. So I made a stepped pin. This is 6mm down here to fit inside the casting, and has a 5mm pin on top here. I have the pin in here, and I made 2 sets of parallels. They are clamped together with a toolmaker's clamp, opposing direction. And that way I can line up the back side of the pin, well, this one dropped in. That's a problem. Well, problem is a little bit overstated. An annoyance. So that way I can, if I take the right one, I can put this up against the back side of the pin. And align my carbide pin in front here this way. And this should give me the correct orientation for the first pin. Then I have a second one that goes on here like this. And when I move it up against the pin here, aligns the second one. I can take it out. Take my pin out, and now when I take a 90-degree square, yeah, this is not a precision square, obviously. I get a 90-degree relationship between those two surfaces. I could use a 90-degree precision square in here to align those two surfaces to each other, but there is one constraint missing. This would allow me to have the intersection of these two planes to be somewhere, but not in the center of rotation. But I think the solution with the stepped pin and the reverse offset parallels here should give me a very good result like this. And yes, there is a danger of warping the casting when you do something like that with the torch, but apart from the whole locations, this is not a precision anything here. The only other precision part is the dovetail up here, below this surface here, and the bore in the center for the main rotating axis. Yeah, and I torched some of the paint off. That's a little bit of repair work before I repaint it. Okay, let's get those pins out, get some Loctite in. As I said, we torched it thoroughly with the flame, so everything is very clean. Also, the carbide doesn't care if you heat it to red glowing. It stays hardened carbide. Okay, let's do this. So we have our Loctite. Add a liberal amount of Loctite here. Drop the pin in. Get our alignment parallel. Align it and press it down. Okay. First one is in. Loctite. Whoop. The trick with Loctite 648 is it's quite fast setting, so you don't have all the time in the world to work with it. Okay, let's drop the pin in. There we go. Now we have our 90-degree relationship between those two pins. Yeah, the drafting triangle is a little bit comical, but as you saw the error before, that was quite significant. So it's just to give me an idea if I messed up again. And I'm fully aware that I did a rant about comments in my last video, and I see the irony that one of the comments pointed out what I did wrong here. Also, thanks to Daniel H. on the Insta-Machinist Discord, who helped me think along with the alignment process. I have the index pin and its eccentric bushing in the casting, and currently it's pretty much on center of the banana-shaped slot. So let's drop the swivel part on here. move to the extreme end and align or set our dial to 0. Okay, there is 0, and that's a nice 90-degree swivel. There's a little bit of parallax error going on. Okay. Now we can spin the eccentric bushing by 90 degrees roughly. Drop it on here. Now of course our 0 doesn't match anymore. We have to align that. That's the idea behind the eccentric bushing, of course. So we are, well, 0-ish. And we are 90-ish here. Let's move it 180 degrees. Just facing basically backwards to our first try. So we're even further in. Zero it out. And there is 90 degrees. So that should have fixed it. Let's look at the situation on a piece of paper. This is the old situation that I had in the last video, and let's draw a line here. The red item here is basically the split in half Dbit that I used to get this surface in alignment with the center line of rotation, which was in hindsight wrong. I get a 90-degree relationship between the two 5mm diameters up here and here. This is 90 degrees, but it's only 90 degrees at 64.3 millimeters, which is the center of the banana-shaped slot. If I move it out or in, the 90 degrees change, which now it's obvious, but somebody had to point it out to me so I could notice it. So that's egg on my face, I guess. New version is this one. Now I have a 5mm pin in the center line here, or in the center. And here are my two 5mm stop pins. In reality it's only one of course, but I'm drawing both end stops. And I'm aligning this surface to be tangent with the OD of a 5mm pin in the center. So no matter where this pin sits, if it sits out here, it's still a 90-degree relationship between each other. If it sits in here, still 90-degree relationship. So I think that's correcter than the first one. So I hope this explanation was helpful. That's also a lesson to me in humility, and that mistakes are real. So thank you all for watching. I'll be back.